Today, we'll be looking at how to read a map, the use of the map and compass, and ways of determining direction without a compass. Successful wilderness travel requires you locate your destination and the route best suited to reach it. You must also be able to find your position while traveling. To accomplish this, you need a map and compass. It is as important for the tripper to be able to read a map and use a compass as it is for a cook to read a recipe and use a kitchen. Since the Earth is oval, it cannot be accurately portrayed on a flat surface. As a result, all maps will have some element of distortion. For wilderness travel, you need a topographic map, which shows changes in elevation. This should be distinguished from a conventional road map. Called planimetric, it shows the Earth's surface as flat. To locate an area a map covers, you require coordinates in degrees of latitude and longitude. The median for determining latitude is the equator. Located midway between the North and South poles, the Earth's surface to the north and south is divided into 90 equal divisions. These are a series of circles drawn parallel to it. Each circle is referred to as a parallel of latitude, starting from 0 degrees at the equator to 90 degrees at the north and south poles. Each degree of parallel is subdivided into 60 segments called minutes. To establish latitude, you must determine the number of degrees and minutes north or south of the equator. The median for longitude is a baseline known as the prime meridian. It is a north-south circle which passes through Greenwich, England. This is also the basis for Greenwich time. To establish longitude, the Earth's surface is divided into 360 equal portions known as degrees. When facing north from Greenwich, each degree to the left is designated by consecutive numbers west, while each degree to the right is designated by consecutive numbers east. Longitude 180 degrees east and 180 degrees west coincide. Using these determinants, you are able to locate an area as being so many degrees and minutes east or west of the prime meridian and north or south of the equator. These bearings will be shown on a map as points of reference. To identify a specific point on a map, you use a grid. This is a series of horizontal and perpendicular lines drawn across the face, spaced equal distance apart. Forming squares, they represent latitude and longitude. Each line is numbered in the margin. You find the square where the point is located. It is identified by the numbers on the adjoining lines to the north and east. Changes in elevation are shown by contour lines. These link points at the same height. A figure in feet or meters is normally inserted to indicate their distance above sea level. By using them, you can calculate the approximate height of adjoining land. You can also define the form of the land by the way in which they are arranged. Those close together indicate a steep slope, and those further apart show a more gentle slope. While they will assist when traveling on land, don't rely on them for a water course. Quite frequently, river and stream channels cut into the land. All maps have symbols. These show natural and man-made characteristics, such as trails, settlements, swamps, rapids, and waterfalls. They will assist in showing the type of terrain to be traveled, and they also provide reference points while en route. A list of symbols and what they represent is normally found in the margin under the heading Legend. When charting trails and roadways on the map, check its date of preparation or printing. This will be shown on its face. Be aware they can change or disappear with time. Maps have a graphic scale, which accurately compares the distance on its face with a similar distance on the Earth's surface. Normally found at the bottom, it allows you to measure the distance of a course of travel, compare it with the scale, and determine the actual distance on land or by water. When using a map to plan a trip, always allow for extra time. You will undoubtedly meet obstacles and obstructions which will delay your progress. To find the direct distance between 2 points, lay a straight-edged instrument on the map between them. Mark the distance on the instrument and lay it along the graphic scale. When the route between 2 points is not straight, normally the case with wilderness travel, the distance can be calculated with a piece of string or rope. Lay it over the route covering all parts from start to finish. Mark the length, then lay it along the scale. When reading a map north of the equator, the direction north is at the top. Called true north, it is in line with the geographic North Pole. This must be distinguished from the magnetic North Pole, which is the direction faced by a magnetized compass needle. In North America, these two directions are the same only along the Agonic Line. This is an imaginary line which runs through Hudson Bay, Lake Michigan, and the state of Georgia. When determining direction at any point west of this line, the magnetic North Pole is east of true north. If east of the line, the magnetic North Pole will be to the west. This variance is referred to as declination. Most maps have a graph which shows the degree of declination and the date it was calculated. While it will change slightly with the passing of time, the figure stated can normally be relied on. Some maps provide for the annual change. To effectively use a map and compass, you must know this variance. While a compass needle normally points towards the magnetic North Pole, it may not, due to interference. This can be caused by local mineral deposits or strong radio frequencies. Either can destroy its function, resulting in a false reading. You can check for accuracy in the following manner. Place the compass at the top of an area map with the needle pointing toward the magnetic North Pole. Note the degrees of declination stated on the map. Mark a point on the compass ring where if east of the Agonic Line, the degrees are added, and if west, subtracted. If there is no interference, the point marked on the ring should align with the direction true north on the map. If the point marked doesn't align, there is interference. Any variance must be noted and applied to future readings. After moving a distance from your first reading, take another. In this way, you can confirm whether the interference still exists or whether it has varied. The compass face is normally marked in degrees, from 0 to 360. True north is 0, east 90 degrees, south 180 degrees, and west 270. These markings are invaluable when making comparable map readings. The price range of compasses varies depending on quality and features. When selecting one, don't sacrifice quality for price. Two features are essential for wilderness travel. The first is the way in which the capsule suspending the needle is filled. It can be either liquid or air. If the needle is suspended in air, it will revolve freely. This makes it difficult to steady and align. If the capsule is filled with liquid, there is more resistance to movement. Readings are easier to fix and, as a result, more accurate. Select a compass which is liquid-filled. The second is the form of the base, which can be either round or rectangular. The latter is preferable. A flat edge can be placed along grid lines on the face of the map for easier reading. To move between any 2 points, you have to locate the route and find its direction. Unless on a straight course, your direction will vary as you progress. This will occur as you go around obstacles and obstructions. Start by marking your intended route on the map. Unless traveling an established trail or waterway, as you progress, check from time to make sure you are on course. This is done by taking a bearing, which is a compass reading, in line with the map. Lay the map on a flat surface. Then place the compass on it, with the direction north or 0 degrees on the ring in line with the direction true north on the map. Unless you are on the agonic line, the needle will not be aligned. Note the direction of travel on the map and the number of degrees it bears to 0 degrees on the compass face. Next, take the marked degrees of declination. Depending on where you are located, add or subtract them from the number of degrees your direction bears to 0 degrees on the compass. If east of the agonic line, add. If west, subtract. Mark the point on the compass face. This will give your map bearing with reference to the compass needle. It allows for the variance between the direction of the needle and the true north on the map. Before moving on, let's quickly review what we have learned about maps. For wilderness travel, you require a topographical map. There are determinants of latitude and longitude. Latitude is calculated from the equator and longitude from the prime meridian through Greenwich, England. A grid is a network of lines used for locating a specific point. Contour lines show changes in elevation, while symbols indicate various natural or man-made characteristics. The graphic scale allows you to compare distance. For a direct course, you use a straight-edged instrument, while string or rope is used for a circuitous route. The variance between the directions true north and magnetic north is called declination. Shown on a map, you add the degrees if east of the agonic line and subtract if west. We have looked at the compass and the manner of checking for interference. And finally, we have seen how to take a bearing, which is a compass reading in line with a map. Whether traveling in a straight line or not, as you move along, you should stop from time to time and take a bearing. This practice will allow you to assure whether or not you are on course. For this purpose, you must locate your position on the map. This is accomplished by looking around and locating two recognizable features which can be identified on the map. In this case, we have a radio tower and an airbase. Rotate the map so its general direction is in line with the direction of the feature. You don't need an exact bearing. For example, if the feature is to the west, the direction west on the map should be facing it. Then take a straight-edged instrument and place one end beside the feature on the map. Here it is, the radio tower. Then move the instrument to line the other end with the tower itself. Holding it firmly, draw a line across the map from the feature as marked towards the tower itself. Next, place the map so its direction is in line with the second feature. Place one end of the instrument beside it on the map. In this case, it is marked as an airbase. Move the instrument so the other end of the instrument is lined with the base itself. Draw a second line. These two lines will intersect. Where they meet will mark your actual location on the map. Sometimes you will not be able to locate or identify two objects. When this happens, try to locate at least one, using it as your bearing point. When traveling on open water, it can be a bay or island. In a river channel or on a trail, it can be a sharp turn or bridge. Or it can be a high point of land, identified from contour lines. Don't think it is easy to compare objects from sight to those on a map. This only comes with practice and experience. When in the wilderness, never travel at night. Not only is it impossible to take bearings, but you will become disoriented and lose your sense of direction. If you do become lost or disoriented, don't panic. Stop and think out your alternatives. Look for some identifiable object. If all else fails, head for the highest point of land. This will allow you to see the surrounding area. You may be able to locate a trail or watercourse which you can follow, or some identifiable object for a bearing point. It is a proven fact that if you travel without a sense of direction, you will move in a circle rather than a straight line. If it appears certain you are lost, consider the alternatives. Movement should be kept to a minimum as it only uses needed energy. If water is nearby, relocate to assure a source for drinking. When it is warm and there are insects, head for an open space. If it is cold or the weather is bad, find shelter. To seek rescue from the air, find a clear area where you can signal and be seen. If you follow the cardinal rule of advising people of your route, the destination point, and estimated time of arrival, someone will eventually come looking. Whether on an extended trip or a short hike, always be prepared for any eventuality. At all times, carry a sharp hunting knife, which will satisfy most cutting requirements. A waterproof container full of matches. And a supply of energy food, such as granola, sufficient to last for at least several days. Also carry extra clothing to assure warmth. Even in hot weather, you need protection from insects and cooler night temperatures. When traveling in an area where fresh water is not readily available, carry a canteen full of liquid. These precautions will assure your well-being. As you travel, observe your surroundings. Look for identifiable objects or features, so if you have to reverse your course, you will be able to find your way. If following a route which you expect to return on, mark your course. Small pieces of colored tape are best. As you return, remove and carry them out so you don't litter the environment. When traveling, stop and rest if you are tired. Eat and drink regularly to assure needed strength and good health. Now let's look at the several ways of determining direction without a compass. With the stick and shadow method, you need cleared, level ground exposed to the sun. Find a stick approximately 12 to 18 inches long and 2 stones. Place the stick upright into the ground. It must be in the center of the area. As can be seen, it casts a shadow. Mark the tip of the shadow with a stone. Then wait approximately 30 minutes. The shadow will have moved. Mark the tip of the shadow again with the second stone. Then draw a straight line between it and the first stone. This will provide the direction of east and west, the location of the first stone being to the west. The orientation to Polaris method can only be used on a clear night. First, you must locate the Big Dipper. Using the two end stars opposite to the handle, draw a line upwards. Continue for a distance approximately 5 times that between the two stars. Here you will find the brightest star in the sky, called the North Star, or Polaris. When facing it, you will be facing true north. While travel at night is not recommended, you will be able to orient the direction to a map for daylight travel. The sun and watch method requires sunlight. Place a wrist or pocket watch on a flat surface. Hold a match or stick beside it vertical to the face. Move the watch until the match casts a shadow directly along the hour hand. In fact, the hour hand will be facing the sun. From 6 a.m. to 6 p.m. Eastern Standard Time, the direction south is a line extending out from the center midway in the smallest angle between the hour hand and the figure 12. Between 6 p.m. and 6 a.m., it is a line midway in the largest angle between the hour hand and the figure 12. If you have a digital watch, don't despair. All you do is mark the time on a paper watch face and follow the same procedure. There is one last method, but it is not always accurate. Look for a tree with moss growing on it. As it thrives on dampness, it will be exposed to little or no sunlight. As the sun normally reaches the east, south, and west sides when crossing the sky, moss should be to the north. Now for a summary. We have seen how to determine your position on the map by aligning two identifiable objects, or if necessary, locating one. We have covered some tips on what to do if disoriented or lost, and how to provide for any eventuality. And we have looked at the stick and shadow, orientation to Polaris, and sun and watch methods of determining direction. These are just the basics. Before venturing forth, study up and practice. Becoming lost is a common occurrence in wilderness fatalities.